Before we start chapter 5, we've got to learn about composite functions. Composite simply means one inside another. And typically, when everybody talks about college algebra, they talk about the Fogg and Goff methods. For some reason, this is one of the only things people remember. By composite, what I'm talking about here is like Fogg simply means the function f of g of x. So what that means is this inner function is inside the outer function. So we have f of g of x. This is the inner function. It of the outer function. So I'll show you what this means in a second. So the other one, Goff, this is the inner function. So the outer function is g, and in place of its variables, I put the function f. For example, let's say we have these two functions here. If I ask you to find Fogg, we would write the f. This word here is of g of x. Now, what does this mean? Because, here's a function name. The function name is f. Whatever's inside the parentheses goes in place of the variable inside the equation. So what this says is I go to the function f. Anywhere I see an x, I put a g of x. So this is my new x. G of x is 3x minus 5. So that's g of x plus 3. And simplify. But what it really means is this. Since g is my internal, I take whatever this function is, this is the inside. Anywhere I see an x, I put that in its place. That's f of g. G of f would be the opposite. Here's my inside function. Anywhere I see an x in the g function, I put the f of x. So I have 3 f of x minus 5. F of x is x plus 3. Distribute, get rid of the parentheses. Combine like terms. And there's our final answer. We'll need this to start off chapter 5. All right, so that's what a composite function is. It's whatever's on the inside, that function goes in place of x of the outer one. Whatever's on the inside goes in place of the x of the outer function. All right, let's look at some examples. Let's look at example 1 here. It says that f of x is 2x minus 5, and g of x is x squared minus 3x plus 8. we have to find f of g of x and g of f of x. Then B wants us to find the same things, but now instead of an x, we have a number. V of g of 1 and V is f of x. All right, so let's begin. What this first one tells us is take our g, and anywhere we see an x in our f function, substitute it. So it's 2 times all of this, x squared minus 3x plus 8 minus 5. Distribute, get rid of the parentheses. 2 times 3 is 6. 16 minus 5. So fog is equal to 2x squared minus 16 plus 11. And same thing with the other function. Whatever my f of x is, anywhere I see an x in the g, I put the f of x function in there. Here, I'll grab each one of those. Now, this first equation, since it's squared, doesn't mean we distribute it. What it means, it's 2x minus 5 times 2x minus 5. So 2x times 2x is 4x squared minus 10x minus 10x plus 25. So that's the first one. Now distribute the negative 3 into both of those. Negative times positive is negative. 3 times 2 is 6x. Negative and negative is a positive. 3 times 5 is 15 plus 8. So this is the first part. This was the second part. And this is the third part. Now combine like terms. We have 4x squared. With negative 10, negative 10, negative 6. 26 x, so it takes care of the x's. 25 plus 15 is 40, plus 8 is 48. And there's your answer. All the composite function is just substitute a function in for a variable. That's all it is. What this one says here, the next one, is you notice it's the same function, except now instead of x's, I have a 7. So what this means is that. So I can either, first off, I could find the f of g. I could do this whole equation here. And once I find this equation, I could plug in 7 for x. So it's 2 times 7 squared, 6 times 7 plus 11. Seven squared is 49. Negative, positive is negative. 6 times 7 is 42. $98 minus 42. So that's 56 plus 11 is 67. We could do it that way. Or we can just do what this is telling us. We could first find, or we can find g of 7. G is x squared minus 3x plus 8. So we have 7 squared minus 3 times 7 plus 8 is 21. It's 28 plus 8 is 36. 36 is what g of 7 is. So I have f of 36. Because this is g of 7, that's the inside. I put this inside my f function. So it's 2 times 36 minus 5. 2 times 36, 72 minus 5 is 67. Whatever makes it easier for you, you can do it that way. If you want to do the composite function first, or find the value first, plug it into the other equation. They both give you the same answer. So this one is g of f of 7. So let's first find f of 7. Two times 7 minus 5. 14 minus 5 is 9. So f of 7 is 9. So I put g of 9. G is x squared minus 3x, so it's 9 squared minus 3 times 9 plus 8. 81 minus 27 plus 8. 81 plus 8 is 89. 8 minus 2 is 6. 9 minus 7 is 2. Which will be the same both ways. I kind of think this other method here is faster. All right. We can also use the same function over itself. G of 1. So I find the inside first. G of 1. So that's 1 squared, 3 times 1 plus 8. 1 minus 3 plus 8 1 plus 8 is 9 minus 3 is 6. So that's g of 1. I plug that inside here. So now I have g of 6, which is 6 squared minus 3 times 6 plus 8. Mm. 36 minus 18 is 18, plus 8 is 26. So there's your final answer. What, pretty straightforward. Yeah, I'm gonna have to because there's no value. I should say, yeah, no problem. Yeah. So what this one is f of x. If you want me to, I can do any one of those the other way if you want me to. All right. So let's review. F of x was 2x minus 5. And since f of f, then f of x is 2x minus 5. I have two functions and they're both f of x. I take the second function, the internal function, which is that. Anywhere I see an x, I put that in there. So f of x is actually 2 times the f of x, which is 2x minus 5. Distribute. They're both negative and add them. So f of x is that. What's that? Because it's not a multiplication, it's a substitution. That's a good question. I never thought about that. 2x minus 5 times 2x minus 5 is actually f of x times f of x. What this is a composite function. F of x, which means this. It's one function inside another. Remember, anything inside the parentheses replaces that variable in the equation. So what this one does is, in our function f, anywhere I see an x that's inside the parentheses, I'll put an f. So it's 2 f of x minus 5. Because that's what's inside the parentheses. Whatever's inside the parentheses goes in place of the variable. So this is 2 times 2x minus 5 minus 5. And that's how we got it. Yeah. 2x minus 5 squared would be if there was just two separate functions multiplied to each other. But this is one function inside another function. All right, let's take an example 2. F of x is equal to radical x, and g of x is x minus 3. Find f of g and g of f. And then their domains. So this first one is f of g of x. So take this, whatever's on the inside, take that equation. Anywhere I see an x, I put that in there, which is square root of g of x. which is the square root of x minus 3. So that's my f of g. So what's the domain of this function? Domain, remember, domain deals with the x values. Are there any limitations I could put on the x's? What does the graph of this look like? Yeah, that's why it's easy if you memorize them. The graph of the square root function looks like what? Right. It starts at 0 and it goes like this. That's it. But now inside there, I have an x minus 3. Here, the smallest I can have is x equals 0. Now I do a horizontal shift. Take the x minus 3, bless you, set it equal to 0, and so my horizontal shift is 3 spaces to the right. So my graph is like this now. So the domain is the smallest it can be is 3, and it can go on to infinity. Or I could say x is greater than or equal to 3. Either one of those. The second one is g of f of x. Since f is on the inside, I take this equation, and anywhere I see an x in the g, I put it in there. So g is x minus 3. So square root of x minus 3. What does this graph look like? Remember, we're still looking for the domain. Shifts, yeah, it's a vertical shift down. But it's the same graph. That's square root of x. This is a vertical shift, so it just goes down 3 spaces. 1, 2, 3. So here's my new origin. The domain is still from 0 to infinity. Or x is greater than equal to 0. Example 3. F of x is 1 over x minus 2. G of x is 5 over x. Same thing. Let's find f of g. Then find g of f. And then their domains. What's the first one going to look like? It's going to be f of g of x, because that's the inside one. So what's the function going to look like now when I plug everything in? Yes, because in here it says inside the f function, anywhere I see an x, I put g of x. So I will take this equation and put it in place of that x. So I'll have 1 over 5 over x minus 2. So we have two fractions on the bottom. We have to combine them. The LCD is going to be x. So this one needs an x over x. So since on the bottom we have a common denominator, they both have x's. What's the rule about a fraction divided by a fraction? By what? The rule is this, is take the top fraction is 1 over 1. Take the top fraction, leave it alone. Multiply it by the flip of the bottom. Since this is 5 minus 2x over x, I flip it. When I multiply these together, so this is our function. So what's the domain? What's the only rule we know about fractions? You can't have what on the bottom? You cannot have a 0. You can have a positive, negative, or anything, any other number, you can have that. You just cannot have a 0 on the bottom. If you do that, that's undefined. So what we do, since we have an equation on the bottom, set that equal to 0 and solve for x. So 5 equals 2x, move that over, and divide by 2. So x is equal to 5 over 2. So when x equals 5 over 2, that makes the bottom 0. So I cannot use 5 over 2. I can use any other number except that. That's my domain. I can use anything except 5 over 2. There's a faster way of doing all this. Two over 1. Look at the top and the bottom separately. What's the LCD of the top and the bottom? This one doesn't have an LCD, so it's a 1 over 1. This one just has an x. So if I multiply the top and the bottom by x, because that's the LCD, what I'll have is x times 1 is x. This one multiplies both of those. So it's x times 5 over x, and then 2 times x. These x's cancel. So all I'm left with is so whenever you have a fraction over a fraction, you just find the LCD of the entire equation of the denominator on top and the denominator on the bottom. So what you're gonna do is you're gonna multiply and get rid of the fractions. And that's what this does. You notice these are the same answers. Let's do the other one. This one Since f is on the inside, it's like this. So since f, this is my function of f, anywhere I see an x in the other function, the g of x, I put that in its place. So we're going to have 5 divided by 1 over x minus 2. You want to use shortcut method or the regular method? Which one do you remember better? Shortcut? So what do you do for the shortcut? Just x? X minus 2, yeah. The LCD is x minus 2. So I multiply the top and the bottom by x minus 2. So on top, I have 5 times x minus 2. And on the bottom, the x minus 2's cancel. So I just have 1. It's just going to be 5x minus 2. So I distribute those. I get 5x minus 10. So what's the domain of this equation? Well, first off, remember, whenever you have a restriction on a domain, if you have like a radical or a fraction, do you have either of those here? No, this is a linear equation. Linear equations go from negative infinity to positive infinity. I could put a negative in there. I could put a 0 in there. I could put a positive in there. It'll all work. Pretty good. Let's go backwards now. Let's say I gave you a function h of x is equal to square root or cube root of 5x squared minus 3. What I'm looking for can you find a function within a function in that example? First off, look for the outer function. What would be, remember, these all have to be in the library of functions. In this example, is there anything that looks like something on that sheet? What? Cube root of x. Yes. So the outer function, the f of x, is the cube root of x. Because that's on the outside. What's on the inside? 5x squared minus 3. So if I was going to check this out, since g is the inside function, I would take this and plug it to anywhere I see an x inside the first function, which is cube root of 5x squared minus 3, which is what I'm looking for. So that's a decomposition. We could break it up into smaller pieces to make it easier for us. Example 4. H of x is equal to 2x minus 3. That's the fifth. to the fifth. Find the two functions f and g. So we're looking for this decomposition. Okay, what's on the inside? Mm-hmm. 2x minus 3. And it's inside what? Something raised to the fifth power. So those are your decompositions. And example 5. We have our h of x is equal to 1 over x plus 3 cubed. Find f of x and g of x. Here's the beautiful thing. There are more than one answers here. Because I can say the inner one, here's solution 1. I can say the inner function, the g of x, is x plus 3. What's the outer function? 1 over x cubed. Or the inner one could be x plus 3 cubed, and the outer one could be 1 over x. Because when I do the composite function, this equation goes in place there, and I have that. So everybody may see a different function, but as long as you can make it a composite function, as long as the outer one is a function that's in the library of functions, you're good to go. And that does it for that section. So that'll get us ready now for